Folks, hello and happy Wednesday. Hope you're having a great week up to this point. Let's see, Chapter 7, another practical. And since we've got a small group here, I thought I would do my part and pitch in a little bit. Um, Whether lucky or unlucky for you, I'm feeling really lazy this afternoon and I don't feel like typing. So I figured what I would do is just throw a quick video together. And what I thought I would do is I am going to take a look at row 20 that has I'm going to talk about everything in the row, but this will cover letters H, J, N, and O. And I think the first thing I want to say here before I get into this, uh, sometimes I see that students have a little bit of trouble understanding that when we talk about allowable increase and allowable decrease in the portion of the sensitivity report that deals with decision variables, the applications here are a little bit different than they are down here in the constraint section of the sensitivity report. So I want to make sure that I highlight that for you all and make sure that it's clear as we finish up the week. So if you remember, one of the constraints you had was a certain number of stamping hours that are available in this process. And it looks like let's see, the total number that you had available was 320. So the constraining value here tells you the number of hours that you have available. And you will notice that as you solved, or this problem was solved, this final value says that you used all of them. And so the first thing we talk about is this idea of shadow price. And the bottom line for shadow price is this: if I have more of this resource, how valuable is it to me? Excuse me. And first of all, notice that the value here is greater than 0. And that's because this constraint is said to be binding, meaning that the final value is equal to the right-hand side, meaning you used all of the resource, so there is value in having more. And as you go down and you look at the constraints that have a 0 shadow price, notice that the final values are less than the right-hand side constraint, or the amount of hours you have available. That's to say that it really doesn't matter how many more hours or how much more of the resource you're given. There's no value because you haven't used what you've already been allocated. So there's two binding constraints here: stamping and assembly. Excuse me. And let's see, 3 non-binding constraints: painting, inspection, and packaging. And so what we need to make sense of now is this and this is money, $571.43. The relationship between shadow price and allowable increase and decrease is this. What we're saying is, if we had additional hours, so if I have 1 additional hour, what happens to the price? Or what happens, I should say, to the final value? Well, what it's saying here, the shadow price is telling you that if I have 1 additional hour, the value of the objective function is going to increase by $572.43. And I can increase the number of hours up to a total of 444 more hours. I'm sorry, 44 more hours. So I can increase the number of stamping hours by 44 hours, and each hour that I get and I add to the existing 320 will increase the final value by $571.43. So if you had 2 additional hours, 2 times 571 is about 1142, 1143 or so. So that's what you would see the increase in the objective function. And just to point out here, when we talk about optimal solution, the final value, or the objective function, is not the optimal solution. The optimal solution is the values of your decision variables once the model is solved. So your optimal solution is here. So the question then becomes, what happens if I lose hours? Well, the same thing works here effectively, but you'll notice here that the allowable decrease is 5 hours. So if I lost 1 hour of stamping, the objective function would decrease by $571.43 up to a number of 5 hours lost. So if I lost a total of 5 hours, 5 times 571 is about $2,800 that you would lose. So anytime you think about a number of hours 5 or less than 5 or more than 44, the shadow price applies. Anything outside of that, the model would have to be resolved. But that is the connection that I want to make sure that everybody makes here between the shadow price and the allowable increase and allowable decrease. These bounds relate to your shadow price, regardless of whether it is a binding or non-binding constraint. But typically what we get interested in is for the binding constraints, what happens to the objective function when we increase or decrease, in this case, the number of hours. Let's see. So that would, so as we talk about H, J, N, and O, that will help you with I, that'll help you with K, that'll help you with L, and that will help you with M. And I think we've already got a couple posts on the board. I think Addie did the reduced cost, which is really kind of the tougher of the concepts in here. That's a tougher one to kind of wrap your head around. So make sure you read Addie's post. She did a real nice job there. Shelley, I just read your post. And the reason I mentioned this idea of the objective function versus the optimal solution, you just need to take one more quick look at that and make sure that you're clear that your optimal solution is here and it is not here. And so, listen, I hope this is helpful. Always, if you have questions, put them on the board here. We can discuss or send me a note, and I will catch up with you later this week. So take care, have a good night, and have a great rest of the week. Take care.